Shri Gurubhyo Namaha children, welcome to our online teaching academy Ekalaiva. Today we are going to see a topic in electricity lesson. The name of the topic is heating effect of electric current. So, these are the appliances usually we used to have in our home, and these appliances used to work under the heating effect of electric current. So, let me explain what is heating effect, how does the electric current has been giving the heating effect. So, we all know that the source of energy for an source of energy in a circuit is a battery or otherwise cell. So, cell is the source of an electric energy in a circuit. So, what is happening inside the cell? A chemical reaction will takes place. Once the chemical reaction takes place, what happens? It creates the potential difference between the terminals, which means the positive terminal and the negative terminal. So, due to that the potential difference, the electrons will started to flow from the negative terminal to the positive terminal. That is how the electric current passes. And what is the role of this source? The source should keep on expend its energy so that the current flow will be maintained in the circuit. Okay. What happens to the energy? The energy will be used up by the particular appliances. Okay. Whatever appliances we are using, it will convert the electrical energy into a different form. Okay. So, that is the role of a source. Okay. And these sources, what will happen? A part of a source of the energy will be used in a usable form. For example, rotating the blades of the fan, or otherwise rotating the blades of the grinder, or otherwise it will make the bulb to glow. Am I right? Okay. And what will happen to the rest of the energy? And rest of the energy will be expended as in the form of heat. Okay. For example, if the fan is running for an hour, for a continuously 1 hour, if you touch and see that the fan, obviously the fan will looks warm. Not only the fan, whatever the appliances, if it is running for a period of time, longer period of time, obviously it started to produce some heat. What is the reason behind it? Let me explain you that. So, look at this picture carefully, and here what happens, and wire has been connected to the circuit. Okay. So that the current passes through the particular wire. Okay. So, once this the current started to flow, what happens? This changes into a different color. Okay. Because it is the heat energy has been produced over there. Okay. But you have to look carefully, only this wire is getting changed into a different color, but not this wire. Okay. Let me show you the other one. So, here also the wire, this is made up of a Necrom wire, and it is also after a few minutes of time it will turn into red hot. Okay. What is the reason behind it is, when an electric current passes through the conductor like a high resistance wire, okay, due to the resistance, what happens? It turns hot. Okay. So, this is the reason behind the heating effect of electric current. Okay. So, in a previous slide I have shown you that only the middle of the wire has been turned into red color or the yellow color. Okay. this part alone changed into a different color. Okay, not this part. This part is not at all affected. What is the reason behind it? Let me tell you with an example. So, obviously we need to talk about the atoms in this case. Okay. So, the wire which is turned into a different color is the nichrome wire. You know that what is nichrome? Nichrome is an alloy. It is the alloy of a combination of nickel plus chromium, and often with iron also. Okay. Yes. So, nichrome is the alloy of nickel, chromium and often with iron. Okay. But here is the picture of the copper I have given. Okay. The wire which is not turned into a different color is the copper wire. Okay. Why it is this nichrome wire is turning into red hot, not this copper wire? Because of the atoms which is present inside the nichrome wire. Okay. So, as I said earlier, nichrome is the combination of different metals, 3 different metals. Okay. So, these different 3 colors will indicate the different metals. Okay. So, you know very well that what is electric current, a rate of flow of charge. Charges has to be moved. Okay. And we also know what is resistance. Resistance means the it will oppose the flow of charge. Okay. So, why it is opposing? Okay. So, usually when the charges are flowing, what happen? These atoms will attract the electric charges. That means electrons, atoms will attract the electrons. So, that what happens? It produces resistance. But in case of nichrome, the bonding between 2 different atoms are more. Okay. Due to that, the electrons are facing a problem to move. That means it suffers more hindrance due to the bonding between the atoms. Okay. Let me take this, let it as a nickel and this is chromium, and because of the bonding between those 2 atoms, they are not ready to release the electrons. Okay. So, that is why here the 3 different metals, so bonding, more bondings over there. So, electrons are suffering to move. Okay. That as a result of it, they are producing the more heat. Okay. What happened to the copper? Will the copper will not produce the heat? Copper also will produce heat, but very less amount when compared with the nichrome. Why? Why is it like that? When the electrons are moving, as I said earlier, they are get attracted by the atoms, so that they are unable to move. Okay. We all know that when whatever the object, I mean for example, when electron is moving, it will have a kinetic energy. Okay. When it is attracted by the atom or when it is collide with the atom, what happened? The kinetic energy will be transferred to the atoms. We also know that law of conservation. Energy can neither be created nor be destroyed. So, that what will happen? The kinetic energy will be transferred to the atoms. So, atoms, we know that as it is a solid, it cannot move. So, it started to vibrate in its own place. So, when it is started to vibrate, it will produce the heat. So, that is the result of heating effect of current. That is why a particular metal or particular alloy produces heat when electric current passes through it. Hope you all understood the concept. Now, let me talk about the law. This law, heating effect of current, we used to call it as Joules Law of Heating. Okay. And this Joules Law of Heating states 3 statements. Let us see that. The first one, the heat produced in a resistor is directly proportional to the square of the current, which means H is directly proportional square of current. Okay. And the next statement, it is directly proportional to the resistance of the given current, which means H is directly proportional to resistance. And the next one, it is directly proportional to the time for which the current flows through the resistor. So, H is directly proportional to T. Okay. Yes. So, let me recall again. The heat produced in a resistor, it not only a heat, energy produced. Okay. So, heat is directly proportional to square of the current, it is directly proportional to the resistance, it is directly proportional to the time. Okay. Yes. Now, let us derive a formula for Joules law of heating or heating effect of current. We also know that the formula for the power, okay, or otherwise energy. Energy is equal to power into time. So, energy, what electrical energy is a product of power into time. So, this can be written as P into T. Okay. And power, how can we define a power? Power is the V into Q by T. Okay. So, power energy, a source of an energy will produce an input of power in the potential difference of V into a charge flowing through that in a unit time. Okay. So, this can be written as power is equal to V into I. This is our first equation. Okay. So, according to Ohm's law, V is equal to IR. So, this should be substituted in the equation 1. So, power is equal to VI and energy is equal to VIT. Now, we need to substitute in this energy. Okay. This energy denotes the heat energy. Okay. Then we can write it as H also. H is equal to VIT. Okay. Now, let us substitute that value in this form. So, this H will become IR in the place of V into I. Into T. So, I and I will be doubled. So, I squared R T. Okay. Now, again according to Ohm's law, I is equal to V by R. Now, we will substitute this in this formula. Then H will become, H is equal to V into V by R into T. So, this will become V squared by R T. So, heating effect of current, Joules law of heating, we can write it as H is equal to VIT or otherwise H is equal to I squared RT or H is equal to V squared by RT. Okay. And when we are doing the problems based on the information the problem carries, we should use the formula. Okay. Now, let us see about the applications. Joules law of heating, the very first application is electric bulb. Okay. So, we know very well that electric bulb, the metal which is there inside the bulb is tungsten. Tungsten, why are we using the tungsten as a filament in the electric bulb means it have the melting point of 3380 degrees Celsius and it is also has high resistance. So, because of these two factors, we are prefer to use the tungsten as the filament in the electric bulb. So, what happens when it has high resistance, the charges will not move so that the heat will be produced over there, that is a result of it, it is giving the light. Okay. And when there is when light keeps on glows and obviously temperature will raised up and what will happen to the glass over there. Okay. Nothing is happening to the glass because the bulb is filled with the inactive gases like nitrogen and argon gases. They are inactive, chemically inactive, so that it will prolong the life of the filament. Okay. So, that is the application of the heating effect of electric current. Let us move on to the next application, fuse. We all know that what is the role of a fuse. Fuse is a safety device which is used in all the domestic circuits so that the circuits or the appliances will be saved when there is a unduly voltage or otherwise more current flows through that, it will be saved. How it is saving? This is also, fuse is also working under heating effect of electric current. So, it will allow a particular amount of electric current through that, so that the wire which is we are using in the fuse should have a appropriate melting point. Okay. So, usually this fuse wire is made up of aluminum, copper, iron or lead. So, fuse wire usually it is made up of aluminum, copper, iron and lead. All these should have the appropriate amount of melting point. Okay. So that we have different values, we used to have different ratings for the fuse. Okay. So, for example, how does it acting as a safety device means, if more current flows through that and automatically it started to melt and it will break the circuit. That is the concept behind the fuse. Okay. And we have so many ratings for fuse. Usually in domestic we used to have 1 ampere, 2 ampere, 3 ampere, 5 ampere and 10 ampere according to our usage. Okay. So, for example, if an electric iron consumes the 1 kilowatt electric power when operated at 220 volt, okay, what type of fuse we have to use? We need to calculate the I. P is equal to VI, I is equal to P by V. So, 1000, that 1 kilowatt is nothing but 1000 watts. 1000 watts divided by 220, we are getting a value of 4.54 ampere. So, in a particular electric iron, 4.5 ampere of current flows through that. In such case, we should use 5 ampere fuse. Okay. So that when 5 ampere of current flows through that, automatically the fuse wire will melt and it will break the circuit. Okay. It will not allow more current to flow through that. Okay. There are different types of fuses are there, and this one is the porcelain type of fuse and this is cartridge fuse. Okay. And usually in this porcelain we used to have the wire over here. This aluminum, copper, lead usually we used to have there. So, what happens? The wire will melt when there is a more current flows through that and it will break the circuit. So, it will be rechanged by manually, we have to rechange it. Okay. But in case of cartridge, we should change the cartridge. Okay. The inside there will be a wire that will get melted up, so that we have to use the different fuse over there. Okay. Now, let us talk about the electric power. Okay. So, in your previous class you could have defined the power as the rate of doing work. but we can also define rate of consumption of energy is also power, okay, which means the rate at which electric energy is dissipated or consumed, okay, consumed in an electric circuit. How much of energy is consumed in a unit time, we used to define it as electric power, okay. So, power usually we denote with the letter capital P, and the SI unit of power is watt, and it is denoted with the capital W. Now, let us define what is watt. Before that, as I said earlier, okay, I have mentioned you that power is equal to VI, okay. So, we can substitute the Ohm's law over there. So, according to Ohm's law, V is equal to IR. So, when I substitute this one, let it take it as equation 1, and if I substitute in that, power is equal to IR into I. So, power will become I squared R. And next, according to Ohm's law, I is equal to V by R. Let us substitute in that. So, P is equal to V into V by R. So, this will become V squared by R. So, P can also, power can be written as P is equal to VI, or otherwise P is equal to I squared R, or otherwise P is equal to V squared by R, okay. So, this is also according to the sum, which whatever information the sum carries, based on that we will be using different formulas, okay. And there is a only difference between power and the Joules law of heating, that is heat, is here we do not mention the time, because time will get cancelled, okay. So, that let me write for H is equal to VIT, and H is equal to V squared by RT, and H is equal to I squared RT, okay. And these formulas, if you add time, then that will become heat energy. If you are not adding the time, then that will be the power. That is the only difference, okay. Now, let me explain about the watt, okay. So, whenever we define whatever, for example, if you define current, we are obviously should know to define the 1 ampere. Same way power we have defined, okay. And here watt, the power consumed by a device that carries 1 ampere of current when operated at a potential difference of 1 volt, okay. So, that is 1 watt is equal to 1 volt into 1 ampere, okay. We also know that 1000 watts is 1 kilowatt, okay. And the electric energy, already I have told you, it is the product of power into time. So, electric energy can be written as P into T, okay. And the unit of electric energy is watt hour, okay. Unit of power is watt, unit of electric energy is watt hour. Now, let me tell you what is watt hour. So, 1 watt hour is the energy consumed when 1 watt of power is used in 1 hour. In 1 hour, if we used 1 watt of power, then that one we will call it as 1 watt hour, okay. So, this 1 watt hour, kilowatt hour is the commercial unit of power, electric energy. Generally we used to call it as unit. in our electricity bills we used to have these many units of current has been consumed. Okay, actually that is nothing but it is the kilowatt hour only, but for commonly we used to say it as units. Okay, and 1 kilowatt hour, there is a relationship between the 1 kilowatt hour and the joules. We can write it in two different ways. Okay, so 1 kilowatt hour, this 1 kilowatt hour is nothing but 1000 watts. Okay, into this hour is 1 hour. 1 hour means we need to write it in the seconds. Okay, that is 3600 seconds. Okay, so when you multiply, what you will be getting? Okay, so that 36 lakhs. Okay, so that has been written in the form of power, 3.6 into 10 to the power of 6 watt second, or otherwise you can write it as 3.6 into 10 to the power of 6 joules. Yes, hope you all understood the concept, and with this topic we are completing the electricity lesson. See you all in the next lesson, see you all in the new lesson. Okay, thank you children.